Hey, today we're going to talk about a few laws that exist in logic, and one of them is related pretty closely to something we just did. So the first law is called the law of contrapositive. So we learned how to write a contrapositive in lesson 41. And here this law of contrapositive says that a conditional statement and the contrapositive of that statement will always be logically equivalent. So we are not going to talk a lot about whether statements are true or false, but the law of contrapositive says that if a conditional statement is either of those, then the contrapositive of that statement will have the same value. So it's important at least to know that a conditional statement and its contrapositive are logically equivalent. So if I asked you to write a statement that is logically equivalent to, if two triangles have congruent angles, then the triangles are similar, we would just simply write the contrapositive of that. So we switch P and Q, and we negate both of them to get, if the triangles are not similar, then two triangles do not have congruent angles. So go ahead and do that for this one. So again, if we want to be logically equivalent, we write the contrapositive. So we switch P and Q, negate them, and we get, if you can log in, then you know your password. So we take the can't out, we take the don't out, and we switch the order. And these two statements are logically equivalent. And that might make sense just reading it, that if you didn't know your password, you won't be able to log in. If you do know your password, or if you can log in, then it means you know your password. So something new is this law of detachment. So in the law of detachment, we're going to have two conditional statements. We've added a new letter in here, R. That's just it's sort of like the conclusion of the second statement, I guess. So if we have two if-then statements, like I have down here in this example, I have P, which is a parallelogram, has 90-degree angles, and Q is, it is a square. So that's something we've done before. Now, if we look at the second statement, in the beginning of that statement is the same thing as the conclusion of the first one. So a parallelogram is a square. That falls in line with it is a square. And then we have this new thing, it is a rectangle. Then we can sort of cut out the yellow part. And we can draw a conclusion based on these two statements that if a parallelogram has 90-degree angles, then it is a rectangle. So basically we end up with the first hypothesis and the second conclusion forming a new if-then statement. So we have a P, a Q, and then Q shows up again, and we have this new thing R. Then we can conclude if P, then R. I want to show you a non-example because here I have a P and a Q. And then if I go look at the beginning of the second conditional, it's the same as the beginning of the first. So P is in the same spot. So it doesn't follow the pattern that we had before. Actually, I copied the same sentence. What I meant to say was, then it is a rectangle. Sorry about that. So you can see we have a third piece here. We have an R, but the beginning of this is not the same as Q from the first statement, so it doesn't work. And given these two conditionals, we can't draw any conclusions. So let's try another one. We want to see if we can draw a conclusion here. So I'm going to highlight P, you are in Pittsburgh. Q is you are in Pennsylvania. I have a new statement, you are in Philadelphia, and then again, you are in Pennsylvania. So in order for us to use law of detachment to make some conclusion, You are in Pennsylvania, the ending of the first sentence has to be the beginning of the second sentence. That's not true, so we can't draw a conclusion. So go ahead and pause and see if you can draw a conclusion, or if possibly there is no way to. So I'm going to highlight a polygon has 5 sides. That's my P. It is a pentagon is Q. The beginning of my next statement is a polygon is a pentagon, so that's Q again. And then I have something new, and we call that R. Its angles add up to 540 degrees. So we can, and I'm going to use my pen, we can get rid of these two pieces and conclude that if a polygon has 5 sides, then its angles add up to 540 degrees. And the last law is called the law of syllogism. This time we're going to have one if-then statement, and then we're going to have a simple statement. And this simple statement needs to go along with P, and then we can draw some conclusion about Q. So in my example, if it is snowing, I'll get my highlighter back. It is snowing is P. We will not have school is Q. And then I have an example, it is snowing today. It is snowing today represents an example of the hypothesis, P. So if we have a case where we have if P then Q, and then we have this simple statement here that's an example of P, we can make a conclusion that we will not have school today. And that conclusion is going to be about Q, the conclusion. Here's a way that it doesn't work. We have it is snowing and we will not have school today. But this simple statement is about the conclusion of my if-then. So we can't draw any further conclusions from these two statements. For example, we could not have school because it's the weekend, or it could be a holiday. So we couldn't conclude that since we don't have school, it's snowing. So let's do another one. I'll highlight my P. A quadrilateral has only one pair of parallel sides. Q is it is a trapezoid. So I need this next statement to be about P, the hypothesis. Quadrilateral ABCD has one pair of parallel sides. That's an example of P. So that falls in line with the law of syllogism. So we can make a conclusion that quadrilateral ABCD is a trapezoid. So go ahead and pause here and try this one. So I'm going to highlight you are watching this video. That's my P. You are on YouTube is Q. And my example is about watching this video, lesson 42. So since this is an example of the hypothesis up here, we can conclude that you are on YouTube. So I have 3 for you to try, 1 for each law. Do the best you can. Make sure you submit your answers on the Google form, and we can answer any questions, go over it in class.